Let's take a look at the math task in class 2.3, get to the point. So, Carlos and Carita need to clean the storage shed where they plan to board the pets. They have decided to hire a company to clean the windows. After collecting the following information, they have come to you for help deciding which window cleaning company they should hire. So we've got two cleaning companies. Sunshine Express, who charge $50 for each service call. So a service call would be every time they come out to clean your windows, plus $10 per window. Then we've got Painless Window Cleaners that charges $25 for service calls, so every visit, plus $15 per window. So the question here is, which company would you recommend and why? Okay, so we need to be able to provide some sort of evidence to Carlos and Clarita of which company is the better company to choose. Okay, prepare an argument to convince Carlos and Clarita that your recommendation is reasonable. Essentially, we need to show it with math. So, there's some multiple ways that we can do this, right? So those models we have, those math models. You could do a table, a graph, algebra, or an equation would be something else we could do. A picture, diagram, something like that could be helpful. So let's start with an equation. People seem to like equations. We use those a lot in math, right? So how would we make an equation here? Well, honestly, I think if you want to make an equation, the easiest way to make an equation is to first make a table. I think that's the best way to start. So we've got Sunshine. Okay, so we'll make a T-chart, a table. So what's the connection here? What's the two things? Well, they're charging per window, right? So probably the number of windows and the cost. So if they just come out, but they don't wash any windows, I know that would seem crazy to do, but that would cost $50, right? So we would start out costing $50. Now, once they got out there and started washing windows, if we had one window, $50 for the service, plus $10 for the window. If we had two windows, plus $10 more, right? And so you see the pattern. So to make an equation, we can use the slope-intercept form because that's a great one in this situation. Because that stands for our starting number, which in Sunshine, so our equation for Sunshine would be y equals, well, we start at 50, right? And what are we doing to 50? We're adding $10 each time. Now, how many times are we going to keep adding $10? Well, till we get to the number of windows, right? So remember, when you're thinking about that, that's $10 is the growth. Okay, and if we did two windows, we added 10 twice. Well, the shortcut of adding 10 twice is multiplying by 2. If we did 3 windows, we'd add 10 3 times. So 3 times 10. So x windows, we go x times 10. Now we could rearrange this to be in that slope-intercept form, 10x plus 50. Okay, that works. So now let's make, with the painless, let's make our T-chart. So number of windows, cost. So here we start out with that $25, and we're adding 15 each time. Okay, so it would be 40 for one window. For two windows, 55. For three windows, it would be 60, 70. Okay, for x windows, it would be to where our equation comes in. So we'd go y equals, we'd start at 25, right? And then we're adding 15 each time. So we'd go 15x, or rearrange it to 15x plus 25. Now, do these equations help us? Can I see what's going on quickly and easily by looking at them? Not really. Okay, this is a case where the equation may not be the best. But look back at our table. Does our table tell us a pretty good idea? What if we only have 3 windows? Well, it's going to be cheaper to go with painless, right? The question is, does that ever change? Because notice that this started out less, but it's growing at a faster rate. Okay, so why don't we continue these tables and see what happens. So let's go up to, say, 10 windows. 3, 4, 5, 6, 7, 8, 9, 10. So that'd be 90, 100, 110, 120, 130, 140, 150. Okay, 4, 5, 6, 7, 8, 9, 10. So this would be 85, 100, 115, 130, 145, 160, 175. Okay, so what do we see here? There's a lot going on, but hopefully the thing you notice first is that 5 windows doesn't matter. 5 windows are equal. So if Carlos and Clarita have 5 windows on their shed, it doesn't matter who they hire, it's going to cost the same. Okay? However, if it's less than 5, that painless is cheaper, isn't it? But what happens at more than 5? Well, now the sunshine is cheaper. So see, this table gives us a really good idea of what's happening here. Okay, whereas the equation, not so much. This is an instance when the table would be a better choice. So we could stop right there and tell Carlos and Clarita, well, depends on how many windows you want cleaned. Okay, if it's less than 5, call sunshine. That would be less than 5. If it's equal to 5, take your pick. If it's greater than 5, go with painless. And then you could show them that table and see this is why. Now you could also do a graph, couldn't you? Okay, if we did a graph, we could count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should go up to 150, huh? Okay, so we'd have the cost here, and we'd have number of windows here. That would be 0. Okay, so then we plot our points. So for the sunshine, we'll do it in red. Okay, so it was 0, 50, and then 1, 60, 2, 3, pretty easy pattern to see, 4, 5, and this is where hand-drawn graphs can kind of be a little less than stellar. Okay, I'm going to have to erase this part. Hope we'll survive. Okay. Now, I could draw a line here if I really wanted to, but honestly, are they going to wash half a window? No, so the dots really would be the better way to do it. So now we start with painless. We start at 25, so we're going to have to go in between there. And then it was 40, and then 2 windows was what? 55, and then 70. So 55, and 70, and 85. Getting closer, and then 5, that's where they were the same, right? So that's that intersection point. We'll make it a different color. Okay, then 6 was higher, and basically it keeps going up and up and up. Okay, so once again, I could draw the lines if we really wanted to, but that wouldn't make as much sense according to our story problem. But just to help visualize, basically looks something like this. So once again, pretty easy to tell. At 5, they're equal, okay? And then as we go to the left, less than 5, it's cheaper to go with the green, which was the painless. Or no, yeah, painless. And then as we get above 100, it's cheaper to go with sunshine. No, I mixed up on these, didn't I? That was greater than 5. That one should have been less than 5. Probably caught that, but there we go. Okay, so this is what we call a system of equations. Okay, when we have more than one equation and we want to see what's going on, and that critical point is where they intersect. So looking at another part having to do with this same story. Okay, so Carlos, it reminds him about those two constraints, the space and the startup cost. Well, what would happen if we graphed these together and found out where they intersect? Now, the problem is, these are in standard form, right? Not so easy to graph. So let's call this the D, and we'll call this C. C for cats, D for dogs, because they were dealing with cats and dogs. So let's solve for D. Basically put it in slope-intercept form. D equals MC plus B, right? Because C is like X, D is like Y. So we subtract 6C from both sides to get 24D equals negative 6C plus 360. And remember, that 6 isn't a number. It's how many C's there are. Okay, so we can't combine it with just a regular number. Then we divide everything by 24. Now, 6 over 24, we can divide them both by 6. So we get D, because that becomes 1, equals negative 1 over 4C plus, now what's 360 divided by 24? Let me grab a calculator real quick. It's 15. So, we can graph that, right? But first, let's see what this one comes out to be. Okay? Startup cost. We'll do the same thing with it. Okay, so 32C plus 80D. So I'll have to scroll down to get my work equals 1280. So once again, same process. Subtract by 32C. We get 80D equals negative 32C plus 1280. Now remember that 32 stands for the number of C's, not the same thing as that number. Then we divide everything by 80. Now, negative 32 over 80. I can divide them both by 8, right? To reduce it. And I get negative 4 over 10, which I can divide by 2's. So we get negative 2 over 5. So D equals negative 2 over 5C plus, now 1280 divided by 80. Choose a fancy-dancy calculator. Double check that. That's 16. Okay? So we get our second equation, D equals negative 2/5 C plus 16. Okay? That's one way to graph it. We could have graphed it a different way since it was in standard form. So let's graph these. So up to 16. So right there's our starting number, our y-intercept, or in this case our d-intercept. And then we're going down 2 to the right 5. So down 2 to the right. So down 2 to the right. Down 2 to the right. And we just keep on going. Down 2 to the right. Down 2 to the right. 5. It's that same pattern. Down 2 to the right. Alright. And we can draw a line and leave it dotted on this case. Okay, often that line is easier to follow. Okay, then we start at 15 for this one, and we're going down 1 to the right 4. Which, now, it looks like they intersect right there, but I wouldn't count on that necessarily being it, because my line wasn't very straight. Okay, so down 1 to the right, 4. Okay, so now, it may be kind of hard to tell what's going on here, where exactly. It intersects somewhere around here. Okay, this is when technology can be very helpful with graphs, because sometimes our graphs aren't right exactly on spot where we want them to be, and that creates a problem. So what I'm going to do is really quickly take a look at Desmos.com. Great online graphing calculator. Makes things a lot easier, and we can use it to check our answer, to make sure that we're on the right track. Okay? Except C was like X, D was like Y. So actually on this, I have to put them as X and Y. Right? And let me get this graph. I'm going to pause it, get it done, and then we'll throw up the graph and see what we get. Okay, so here's the graph, same graph. Okay, the blue line represents our blue line, the purple line represented by the red line. So where they intersect is actually not an exact point. So it'd be 6 2/3, that's what the 0.6667, and 13 1/3. What do they stand for? Well, the X standard for the cats, and the Y for the dogs. So the point where these are the same exact, these constraints are the same exact, is actually not a complete dot. I mean, you're not going to take and cut off 1/3 of a cat, nor are you going to cut off 2/3 of a dog to get this work. But this gives us an idea. So talking about those constraints, up until that point, the major constraint is going to be the startup costs. This is going to cause us so we can't have as many animals. And then beyond that, the constraint, the lower part, is going to be that space. So remember, when we were talking about these were really inequalities. So like shading all over here is going to be where we can decide on how many dogs and cats to have. So it helps us understand that a little better. Okay, same with this one. Okay, two other constraints. So let's change it to 12x plus 20y. Okay, and then we subtract 12x. Okay, because we're calling that D, not C, which is y. We're calling this the x, which is C. So once again, same idea. So we get 20y equals negative 12x plus 480. Divide everything by 20. Okay, we get y equals, we can divide that by 4, negative 3. 20 can be divided by 4, negative 3/5 x plus 480 divided by 20 would be 24. So I believe this only goes up to 20. So we actually start a little higher. So 1, 2, 3, 4, right up there, we'll say. And then we go down 3, 1, 2, 3, under the right 5. It's right about there, down. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, and then 1, 2, 3, 4, 5. You guys just love to hear me count, don't you? 3. Doing it in my head now. Well, maybe does it go up to 30? 1, 2, oh crap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Went up to 25. Dang it. So we could have went 24. Oh well. That kind of sucks. A little extra work. No problem. So 1, 2, 3, 1, 2, 3, 4, 5. There we go. Okay. So there's that one. Now pampering time. Same idea. 16. X we'll say plus 20. Y we'll say. So it looks a little more like a graphing equation. Subtract by 6x. Notice we're doing the same process to change these standard forms into slope-intercept form. Divide by 20. So we get y equals negative 16 over 20 would be negative 4 over 5x. But notice it's going to be plus 24 again. So really, I already know where these two are going to intersect, don't I? Right there. The same place. And why did I write 41? That should have been 24. You guys got to check me on that stuff. So now we're going down 4 to the right 5. So down to the right 5. So it has a steeper slope, doesn't it? Okay. So that point where they intersect is actually the y-intercept at 24. So that pampering time is always going to be less than the feeding time, which means that's going to be our major constraint as opposed to this one. Okay, and if we wanted to double check that, we can see it again here. Okay, where do they intersect? Right there at 0, 24. So beyond that, because when we're talking about those constraints, it'd be more of an inequality. Right, there we go, guys. So that graphing those, the whole point, graphing two equations together, we can find that intersection point. That intersection point tells us a lot of information.